Chapter 5 Volcanoes 5.1 Introduction to Volcanism. About 2/3 of active volcanoes at the surface of the earth are in the Ring of Fire, seen in this image in orange. Volcanoes are formed as molten rock, known as magma, rises to the surface. When the magma reaches the surface through an opening, known as a volcanic vent, the molten rock is known as lava. Term review: magma below the surface, lava on the surface. So where does magma come from? Most magmas come from the asthenosphere, that weak but not liquid layer of rock in the top portion of the mantle, but below the lithosphere. There are three ways that silicate rocks melt. 1. Decompression melting, when pressure exerted on hot rock is decreased. This happens at divergent plate boundaries, continental rifts, and hot spots. 2. Addition of volatiles. Volatiles are chemical compounds that lower the melting temperature of the rock. Examples include water and carbon dioxide. And 3. Addition of heat. As magmas rise, they release heat to overlying rocks. The resultant magma can have varying properties due to different silica content and volatile content. The higher the silica content, the higher the viscosity, i.e. lower the flowability. Silica-rich lava has thick, goopy flows, as seen in this image of a rhyolite flow in Mono, California. Silica-poor lava has thin, runny flows, as seen in this image of a basalt flow. Silica is predominant in many light-colored minerals, such as quartz and feldspar. And silica-poor minerals contain relatively more iron and magnesium that form many dark minerals like amphiboles. With this in mind, it should not be surprising that rocks formed from silica-rich lavas and magmas are lighter in color, and rocks that formed from silica-poor lavas and magmas are darker in color, and rocks that formed from lavas and magmas with an intermediate amount of silica have an intermediate color. These rock images show rocks that form from lava on the left and magma on the right. Rocks that form from lava means that the lava was extruded on top of the surface of the earth and cooled very quickly, so no large crystals formed, which is called aphanitic texture. Rocks that form from magma means that the magma intruded into the earth near the surface, but not at the surface. As the rocks cooled slowly under the surface of the earth, crystals have much more time to form, so they grew bigger, which is called phaneritic texture. Phanero is Greek for visible, meaning in this case you can see the crystals in the rock. The prefix a means without in Greek, so aphanitic means without visible crystals in this case. Notice, for both the extrusive and intrusive rocks, the average color becomes lighter and pinker as the silica content increases. Basaltic lava contains less silica than rhyolitic lava. Gabbro has more mafic minerals that contain relatively higher amounts of iron and magnesium than does granite. Volatile content also varies. A high concentration of dissolved volatiles leads to a violent eruption, as seen in the top picture, whereas a low concentration of dissolved volatiles leads to a calm eruption, seen in the lower picture. Volatile content generally increases with increasing silica content. In explosive eruptions, tephra and pyroclastic debris form. All materials, which include all materials that are ejected from the volcano, such as ash, lapilli, and bombs. Gases break lava into small pieces to form ash fragments, or into frothy foam that later solidifies as pumice. A pyroclastic deposit is an accumulation of tephra, or pyroclastic debris. 5.2 Volcano types, formation, and eruptive behavior. These are the types of volcanoes we will briefly discuss: shield volcano, fissure volcano, strato or composite cone, lava dome, cinder cone, and continental calderas. To compare their relative violence during eruptions, we use the Volcanic Explosivity Index, or VEI. The scale ranges from 0 to 8. It is mostly logarithmic, except for 0 through 2. It is based on the height of the plume, the volume of ejected material, and the overall violence. Shield volcanoes are the largest volcanoes in the world and are built almost entirely of thin basaltic lava flows. They are common in Hawaiian Islands, Iceland, and Indian Ocean, and often form lava tubes underground. The shield volcano may have a central vent, as in the Hawaiian type eruptions, or it may have a fissure vent, as in the Icelandic type eruptions. The basaltic lava has a low volatile content, and so has a low volcanic explosivity index of 0 to 1. Composite volcanoes, or stratovolcanoes, have a large cone shape. The magma is often more viscous, with a higher volatile content. It erupts a variety of lava types, including pyroclastic deposits and lava flows that are, on average, andesitic, though specific lava flows can vary from basaltic to rhyolitic. The volcanic explosivity index ranges from 2 through 6. Examples include Mount St. Helens, Mount Rainier, and Mount Fuji, as seen in this image. Shield volcanoes are much bigger than composite volcanoes, as shown in this image. Mauna Loa and Kilauea are shield volcanoes that rise through the ocean and beyond. Mount Rainier is a large composite volcano, but is tiny in comparison. Lava domes are made from highly viscous magma, andesitic to rhyolitic. The eruptions can be highly explosive, though small in size, with a VEI of about 3. Small domes often form within the crater after an eruption. Examples include Lassen Peak in the image and monocraters. Cinder cones, sometimes referred to as scoria cones, are small, steep-sided cone-shaped volcanoes composed of tephra and basaltic lava flows. They are common on larger volcanoes, normal faults, or along cracks and fissures, and have a VEI of 1 to 2. An example is Paracutin, Mexico, as depicted here. The most famous cinder cone grew out of a cornfield in Mexico in 1943. From a new vent, eruptions continued for 9 years, built a cone to a height of 424 meters, and produced lava flows that covered 25 square kilometers. Read more about it in your book or online. Continental caldera eruptions are very rare, extremely violent eruptions that produce huge amounts of ash and form calderas. It produces primarily rhyolitic lava and is sometimes referred to as supervolcanoes by media, with a VEI of 6 to 8. Most recent North American caldera eruptions were 640,000 years ago at Yellowstone National Park and 700 million years ago at Long Valley, California. The image depicts ash fall zones for 3 Yellowstone eruptions, which cover a large portion of the United States. Geographic regions at risk from volcanoes. 5.3. Geographic regions at risk for volcanoes include the Ring of Fire, hotspots, mid-ocean ridges, and rift valleys. This image shows risk from the volcanic hazard in the western United States for the next 15,000 years. Note that the ashfall hazard is much more extensive than the lava and pyroclastic debris type hazards depicted in red and orange. Also note the Yellowstone ashfall hazard isn't even depicted. The authors may not have considered Yellowstone as a hazard in the next 15,000 years. Are you at risk from the volcano hazard? (5.4) Effects of volcanoes. Lava flows result when magma reaches the surface through crater or from a vent. There are 3 types: basaltic, andesitic, and rhyolitic. Basaltic is the most abundant and the most rapid at 15 to 35 kilometers per hour. Pahoehoe lavas depicted here are smooth and ropey. A'a lava is also depicted here, forms blocky flows. Pyroclastic activity is explosive activity in which tephra is blown into the atmosphere. Here are some images of tephra being formed as it is exploded from the volcano, and tephra once it has cooled to lapilli and lava shaped like bombs. Pyroclastic activity also includes volcanic ash eruptions, where fine-grained rock and volcanic glass shatters and gas is blown into the air and settle as an ashfall. These images we see ash from a volcano and ash that has settled on a truck. Pyroclastic activity also includes material from a lateral blast, such as rock fragments, are blown horizontally from volcano at high speeds. A pyroclastic flow, also known as ash flows, hot avalanches, or nuits ardentes, are avalanches of hot ash, rock, volcanic glass fragments, and gas that flow at 160 kilometers per hour with temperatures greater than 100 degrees Celsius. They incinerate everything in their paths and are responsible for more deaths than any other volcanic hazard. Here is an image of a pyroclastic flow down the side of a volcano. And here are some plaster casts of volcano victims from Mount Vesuvius that perished in a pyroclastic flow. Ashfall may destroy vegetation and contaminate surface water by sedimentation and changing the pH. This can harm aquatic life. Ash accumulation on roofs may cause structural damage, as well as cause irritation of the respiratory system and eyes, and flame out of engines of jet aircraft.